All right, let's get started. So once again, this is Javier Ortiz. I'm your mentor throughout this data engineering nano degree program. So today's plan, what we're going to do, I'm going to go really quickly with some announcements, and then I have a presentation prepared for you guys. So let me just share this Slack channel window. And just to remind everybody that this DEND session 963 is our main channel where our study group resides. So please don't forget to check that one out. Each week on Tuesday, I'm posting a week roundup. So this week roundup basically has all the lessons that you need to advance throughout this week, any scheduled events that we have, such as this webinar and the link to access the webinar, the AMA sessions I'm holding one day before the project is due, and the link where you can schedule the one-on-one meeting with me, and the deliverables that we have due that week, reminders, and the shout out of the week to everybody who has successfully completed their projects. So please don't forget to check that one out. All right. And with that out of the way, let's move on to today's presentation. Let me make that big. Okay. Okay, just to do the chat, can you let me know if you can see the presentation correctly? I'm not blocking. Awesome. All right. So today's presentation is about NoSQL data models and Apache Cassandra. So it's basically an introduction of NoSQL data models and some tips and overall approaches to dealing with Apache Cassandra. Okay, so today, first of all, we're going to start with relational databases versus NoSQL. When it's best to use one or the other. Then we'll focus on creating tables based on queries with Apache Cassandra. Then we'll discuss how to define your primary keys, and then we'll have some time for questions and answers. All right, let's get started then. So we have two main types of databases. We have the relational databases, which were the ones that you were creating with Postgres in the first project. And we also have the NoSQL databases, which are the ones that you're going to be creating with Apache Cassandra. So it's really important that you understand the difference between these two and when in real life you would like to use one over the other. So pros and cons of relational databases, which you can call a SQL database, which is the one that you made with Postgres. And this requires you to use predefined schemas. So if you remember from our previous webinars, in a SQL database, the first thing that you do, you define the entities, that is like the things, objects that you want to track data about, and you define the relationship between these different entities. Like what specific attributes do you want to track about these entities, and those becomes your tables, all right? Now, the advantage of this is that this assures you that you don't have any duplicated data across tables and that your tables are always up to date. So let me show it for you. So we have like a really simplified version of a relational database where I have two tables right here. I have an artist table where I have artist ID, artist name, and the number of members of that particular band, the particular artist. And I have also an album table where I have the album ID, the album name, the artist ID, and the city where that album was made. So what I mean with that you don't have any duplicated data with relational database is, for example, right here. I have two albums that were both made by the Beatles, all right? And since I hold the information of that band in a separate table, okay, I don't have any duplicated data regarding the Beatles, all right? So for example, if I were to hold the number of members of the Beatles in this table, I will get duplicated data because I will have the number of members here in this row, and once again in this row, because it's once again another album made by the Beatles. But since I have it in a different table, I just have it once. So that makes it really easy to update, because for example, right now, the Beatles are no longer a band, but let's say that now they're a two-piece band, okay? If I were to have it like in different rows, I would have to update each row where I had that specific data point. But since I just have it once because I have like a specific table dedicated to that, this I just update it once and it's updated in my whole database. So that's really, really cool, because you assure that your data is always up to date. Awesome. Now, some cons is that a change in the structure would be difficult, and these databases can be not fast enough. So what do I mean with that? So let's say that now I want to track another entity, like, I don't know, the record company to where each band belongs. I will have to create a separate table because that's a different entity, and I will have to define the relationship that that entity has with all the other tables in the data set. So it can become difficult. And now, for example, let's say that I have a query where I want to return all the information about an album plus all the information about the band that made that album, like the number of members, all right? So if I want to get that specific query, I need to join both tables, which is not a big deal when you only have two tables. But imagine that you have a query that you need to join 4, 5, 6, 7 tables, all right? That can become difficult. Now imagine that you don't have like just one user doing this 6 or 7 joins, but you have a million users doing this 7 joins. So that can get out of control, and that can become really, really slow. So this is one of the biggest cons of a relational database. Okay, so taking into consideration the pros and cons of relational databases, these databases are best for predictable and structured data and a finite number of users. What I mean with this is that if you need your data to always be up to date, and you know that the data is not going to throw at you like new entities or like a new unstructured something that you didn't expect, and you have like a finite number of users, then this is your best table. For example, companies in the finance sector, or if you're running like an inventory that you need your data to always be up to date, and you have just like a definite number of users, this is your best choice, all right? So this is when you should use the relational databases. Okay, any questions about relational databases? No, we'll continue to pros and cons of NoSQL databases. All right, so NoSQL databases, NoSQL stands for not only SQL. So we use SQL, but it's just not a relational database. It has a dynamic schema for unstructured data, and data is stored in many ways. So the main difference regarding the NoSQL database and the relational database is that NoSQL database, these tables are created based on queries, all right? So you don't need to define the relationship between the different tables, all right? Basically, all the information that you want a certain query to give you, you hold all that information in the same table, okay? So some of the benefits that this brings is that these tables are really fast in order to provide back information, and you can create new tables easily for new needs. So for example, right here, I have a table, a NoSQL table, and this gives me the information of the city, the artist name, the number of members, and the album name. So if I have a query and I know that I want these 4 data points as a result, I just can hold all these 4 data points over here, and I don't need to join any tables to get that information. I'm holding in my table all the information that I know that I'm going to query later, or that a user is going to query later. So it's really, really fast because I don't need to join any tables. And let's say that now I don't just want these 4 data points. I want, I don't know, another 4 data points like a record company and the status of the album sales, like it's platinum or silver or gold. I just can hold all that information in a different table, and so that I can query that information in the other table. I don't have to think about the relationship between these 2 tables. I just, all I care about is that my table gives back the information that I'm going to query. Okay, and there are no joins in the NoSQL databases. So these are really fast, and you can create new tables really easily. But some cons is that you have duplicated data across different tables, and that some tables may not be up to date. So right here, we can see that the number of members for the artist, it's duplicated like many times. I don't know, if I have like 10 albums by the Beatles, I will have this number of members 10 times, all right? So I have duplicated data over here. And not only in the same table, but across tables. So for example, if I have another table that I used to query the record company, but also provides with the artist name and the number of members of that artist, I'm going to have the number of members and the artist name in a different table as well. So I have duplicated data across the same table and across different tables. Having that in different tables makes it hard to update, because let's say that in this particular table, I update the number of members of the Beatles from 4 to 2. Since I also have this column in another table, that table won't be up to date because I just updated this table. So this is up to date, but the other table is not up to date. Maybe eventually I will update it, but there will be a time when both the 2 tables will give you different results if they're not updated. So taking into consideration these pros and cons of NoSQL databases, these NoSQL databases are best for organizations where the number of users dynamically fluctuates or that need really fast results, such as in a startup or let's say Netflix. So in a startup, they don't have their data that is structured because they're figuring out things. So it is not worthy to get married to a defined schema if you're going to start tracking different things that you haven't considered. And if maybe, I don't know, the number of users jumps from, I don't know, having 5 one day and the following day having 1 million users, you want to be able to, you want your database to be able to handle those fluctuations, all right? And for example, Netflix as well, if you want like really, really fast results and you know you're going to query, I don't know, the information about a certain movie, and you want to create that really, really quickly because your users expect that speed, all right? So these 2, the relational databases and the NoSQL databases, both are great, but it just depends on the organization and the needs of the organization, all right? So if you don't have any questions regarding the relational databases, NoSQL databases, or when to use them, we can move on to how to create the tables of our database. All right, let's move on then. So Apache Cassandra is a NoSQL database and is the one that is the focus of the current lesson in your program. Now, how do we create tables in Apache Cassandra? We create them based on queries. So as I stated in the previous slides, you don't define the relationship between tables. You really don't care about. What you care is that your table is able to answer a specific query. So for example, right here, I first need to think of what my user is going to ask. So I know that my user is going to ask to give every album in the music library that was created by the Beatles at Liverpool. All right, so that's one example of a query. So the first thing I'm going to do, I'm going to try to write that query. So select Then I want the table to give me all the information that I'm asking here from, and then I'm going to name my table. I'm going to name it music library because it was returned right here. And I know that I need to partition my data by artist name because I know that I want only the albums that were created by the Beatles. So where artist name equals the Beatles. One second over, sorry. All right, so where artist name equals the Beatles and city equals Liverpool. All right, so these two are going to partition my data. And I know that by running this query, I want to get the following results. I want to get the album name, it's going to be Let It Be. I want to get the artist name, it's going to be the Beatles because that's how I partition my data. And I want to get the city, okay, it's going to be Liverpool. So now that I have the SQL query and an example of the results that I want to get by running that query, now I can proceed to write my table, okay? And we write it with this statement: create table if not exists, and then the name of my table, which is going to be music library, as I mentioned it here in the SQL query. And then the first column, I know I want to return the album name, so it's going to be album name and data type. I know I want the artist name, so that's going to be artist name and the data type. I know I want the city, so city and the data type. And then I define my primary key. And I define my primary key by the way I partition my data in the where statement. And this statement would create this following table: album name, artist name, and city. And I can insert my values to make this table. All right, so the most important thing that you need to remember is that you're going to create your tables in NoSQL database based on your queries. All right, so now that we have that settled down, how do we define the primary key? Now, this is by far the hardest part, I would say, of the next project. So you really want to understand that. And I'm going to provide you with 2 simple tips that will help you understand what your primary keys are going to be. The first tip is, if you have a where statement in your query, that is your primary key. All right? So that's really, really simple to remember. For example, in the previous query, this was the previous query, select everything from music library where artist name equals the Beatles and city equals Liverpool. Right here, since I have a where statement where I have the artist name and the city, okay, these two, this is how I'm partitioning my data. So these two are going to become my primary key. And that's as simple as it gets, all right? All right, so for example, right here, I have another one that says, give me the artist, song title, song's length in the music app history that was heard during session ID equals 1, 2, 3. All right, and what I have here, this is like the query that I want to answer. So I'm going to start by writing the SQL query. So I'm going to select everything from song history. You can name your tables as you wish. And I want my data partitioned by the session ID. So where session ID equals 1, 2, 3. Now I'm going to write an example of what this query will return. So we'll return the session ID, the artist name, the song title, the length, and that's it. Okay, so when I write my create statement, it would say create table if not exists, and song history, and my columns would be session ID, and I can define the data type, then the artist name and the data type, then the song title and the data type, the length and the data type. And from what we remember of using this tip, our primary key is going to be whatever we have here in the where statement. So primary key is going to be our session ID. And it's really that simple. Okay, whatever you have in your where statement, that is going to be your primary key, because that's how you want your data to be partitioned. Okay. Now, there will be some cases where you need, you have a where statement, but you also want your data to be sorted by a particular column. Okay? So if you have a where statement in your query, but you also need your data sorted by a particular column, okay, this is what you're going to do. So the query is give every album in the music library that was created by the Beatles at Liverpool, sorted by year. So I'm going to select everything from music library where artist name equals the Beatles, as was mentioned here, and city equals Liverpool, as I was mentioned here. Now notice that I'm not writing order by here by year. I won't do it here because I'm going to define it in my primary key, and the result automatically will be sorted by year. Okay, so by running this query, I want to return the album name, the artist that created, the city that was created, and now the year that was created. So I'm going to write my query as create table, my statement as create table if not exist, then the name of the table, and then the first result, which is the album name equals text, then artist name, that's the Beatles, right? And then Liverpool, which is the city, then the year, which is an int, and the primary key in this case will be a composite primary key, all right? So the where statement, the way I partition my data, is going to be the first part of my primary key. As you can see, this is inside parentheses, these two, artist name and city, and the column that I want my data to be sorted by is going to be the second part of my primary key, all right? And now this will give me the result sorted by year. So it's really important that if you have a where statement, but you also want your data to be sorted by a specific parameter, you include that parameter in the primary key. Okay, so those are my 2 tips on creating tables in Apache Cassandra. So that's the hardest part by far on the project that comes. So make sure that you understand that, and just think about it. Write the SQL query first, and if you have a where statement, whatever you have in the where statement, that is going to be your primary key. And if you need your data sorted by another column, don't forget to include that as well on the primary key. All right, so those are my main tips. Just to summarize what we cover in this presentation, the best cases to use relational databases are when you have an organization that manages structured data, and you need that data to always be up to date, and you have like a finite number of users, like in finance or in, I don't know, inventories. And for NoSQL databases, you want to use that if the number of users fluctuates a lot, all right? And you need like really, really fast results to your queries. And when you're writing tables in Apache Cassandra, don't forget to think of the query first, all right? Write the SQL query first and write an example of what would you expect, and those are going to become the values, the columns of your table, all right? And don't forget that if you have a where statement, that is going to be your primary key, and that's my best tips on writing tables. So let's move on to questions. So I see one here that is, how is data stored in Cassandra, row-based or column-based? So all the examples that you saw on the lessons, fill it out by rows, and the project you can use an insert that is going to fill it out by rows as well. And HBase. Is there any relation or difference between Cassandra and HBase? And me personally, I haven't used HBase and I'm familiar with it, so I will have to get back to you with that answer. But I will definitely look into that. So sorry. Yeah. Uh, yes. Oh, actually, let me show it to you. The answer to the first question is, how is data stored in Cassandra, row-based or column-based? So let me just go to the project and show you an example over there. Actually, let me just, we still have like lots of time, so I'm just going to give like a brief introduction to the project. So the project, you basically have one Python notebook over here, and when you run this Python notebook, you you will create another file that is going to look like this. All right, and you're going to create your key space, set your key space, and these are the queries that you have to think about. These are the queries that you need to think about when you are when you're creating the tables, all right? So as you can see right here, we have we have a part of the ETL, okay, that is going to run through each. It's basically running through the file that we created that's holding the in CSV, is holding the different data about. It's basically holding this data. Okay, so what we're going to do, we're going to fill out. We're going to write an insert statement that is going to choose from that line, and it's going to fill the information row by row. All right, so like that's answering like the first question. So we're going to define from that specific. So basically what it's going to do is going to go over each row by row, and you're going to select what columns you want to populate. You want to pick from that specific row to populate your table. So basically what you're doing, you're selecting the columns, but you're populating your table row by row. That's what I want to say. And in the project walkthrough, this will be clearer because I'll run the code and you'll be able to see it, but that will be next week. But basically, yes, answering the first question, you're going to select the columns that you want to choose for your table, but because of the code that you write, you're going to populate your tables row by row. All right, and so I have here another question. So share the slides at the end. Yes, I will share the slides at the end. And the question is, how is the data stored in back end? Not really sure what the answer there, but I can definitely look into that. Like in Redshift, all columns data is stored together rather than row values together. Yes, not really sure of the answer, so I will have to get back to you. Sorry about that one. But yeah, I will definitely look into that and ask somebody and ask some of the other mentors to answer that. So that's basically today's webinar. Next week, I'm going to go over the project, and I'm going to run all the code that we need, and I'm going to give an example of writing the first query, and that is going to be basically it. The next project is really easy. Basically, the hardest part is writing the queries, the SQL queries for this, and determining your primary keys. All right. So that's basically all for today. I don't know if you have any other questions regarding project 1 or regarding project 2. All right. So just to remind you, you can set up a one-on-one meeting where we can go over your code of each project through calendly.com/Javier Mortiz. As always, I'm going to share that with you through a Slack channel. Oh, and one more thing that I was forgetting. In the Slack channel, we have right here a right tab. And here, if you go to pin items, you can easily access the week roundups where you can find the Zoom link and the link to schedule the mentor meetings. Right here, also in share files, I'm going to be sharing a file that has all the links to the webinars that we have so far, to the recordings, and also the PDFs of the slides of the presentation. So don't forget to check this one out here through the Slack channel. All right. But is it possible to send the webinars as mid-invite invites instead of just sharing the link to Zoom in Slack? Would I need to send to your email address, like the meet invites, or? Oh, okay. Yeah, the thing here is Udacity's guidelines, like, did you say like this, the only established means of communication with the students is through the Slack channel or through the one-on-ones or the webinars? So that's the reason we just posted over here. But I think Zoom makes it really easy to schedule the event in your own calendar once you open the link. But just don't forget, it's every Tuesday I send the week roundup, and in each week roundup you will be able to find the link. Okay, so if you ever like struggling to find it, don't forget that I always pin it so you can find it really easy that way. All right, so that would be all for today's webinar. Don't forget to turn in to show up for the next week's webinar. Well, I walk through the project number 2, all right, which is due, I think, April 30th. And once again, congratulations to everybody that already turned in their first project and have their project passed. And that's it for today. So thank you very much, guys. Have a great learning week. Awesome.